This is lesson 79, VHDL example 51. And in this example, we'll write a VHDL program for an n-bit counter. This will be a useful program that you should stick in your toolbox so that you can use it anytime you need a counter of any size. We do it in the usual way by including this generic statement in the entity. N is an integer. We'll default it to 8 here. So we'll have the same clear and clock inputs, and Q output is now n-1 down to 0. Then the counter is very much like we had before. We'll have a signal count. Now it's n-1 down to 0. Process clock and clear. If clear equals 1, we want to set all the bits of count to 0. We don't know how many there are, so we put others go to 0. Remember, this sets all the bits in count to 0. Else on the rising edge of the clock, count just gets count plus 1. And then we set Q to count. Here we show a simulation for the 8-bit case. So we have an 8-bit counter, Q0 to Q7. The clock frequency is so high you can't see it here. In fact, you can't even see Q0. Q1 will be half of Q0, so it shows up. Then Q2 is half the frequency of Q1. Q3 is half the frequency of Q2. Q4 half of Q3. 5 half of Q4. Q6 is half the frequency of Q5. And finally Q7 is half the frequency of Q6. So you see we end up with square waves of increasingly lower frequency for each output Q. This will be very useful anytime you want to get a lower frequency. Remember, the input frequency to your FPGA is 50 megahertz. So to get low frequency, in particular like 190 hertz one to run our 7-segment displays, we need to divide the count down with a large counter. And in fact, in the next lesson, we'll write a program for a 24-bit counter that we'll use for a general clock divide that will be very useful.